Right now, we are talking about dependencies. What are dependencies? A dependency is a relationship where one piece of code relies on another to do its job. In Java, this dependency exists when one class relies on another class to do some work, to run some code. So what are we going to talk about today? We're going to talk about the four types of dependencies, starting with dependency itself, followed by association, aggregation, and finishing off with composition. Then we will talk about dependency injection, constructor injection, and setter injection. Let's talk about dependency, which is the weakest form of dependency. In dependency, one class uses another class as an argument. Like I already mentioned, it's the weakest form of dependency. Just think that one class is temporarily using another class. And the relationship is a uses a because, well, they're just using each other. And in the UML, there'll be a dashed line with an arrowhead. And if you look at this example, you have the class payment service, which is dependent on an object of the class invoice to process a payment. This invoice is being taken as an argument by this method, process payment. Next, we have association, in which one class is using another as an attribute. In an association, just think about it as if they know about each other. It's stronger than dependency. And the relationship, I guess you could call it as a knows-a relationship. And in a UML, it's a solid line with an arrow. I mean, yes, it looks like a broken line here, but in a real UML, it will be solid. And look at this class. This is a class employee, and it's using an object of the department class as an attribute. This is an attribute. Next, we have aggregation. Aggregation, it's similar to association. And as a matter of fact, if you take a deeper dive, they're really not that different, except typically in an aggregation, one class is using a collection of classes as an attribute. Just think of it as being an aggregate of many parts, made up of many parts. The relationship is stronger than the association because there's some ownership here. And you can think of it as a has-a relationship, although it's going to be a weaker relationship than the next one. And in the UML, it's a line, it's a line with a diamond head, with an open diamond. And if you look at this sample, you have a class called team using a list of players as an attribute. Composition. So composition, in a composition, one class cannot exist without another class. Examples include inner classes or classes used as final attributes. Okay, the key word is final. The relationship is a strong has-a. It's the strongest relationship. And the UML is a solid diamond. This should be on another line. Okay, let's look at these two examples. In this example, you have a class called car with a final attribute of engine. And if you look at the code, in the constructor, when you instantiate a car, you instantiate an engine, and it makes sense in the real world. If you don't have a car, you're not going to have the engine. So that's composition. This class car is composed of this engine. It has a component, which is this engine. This house. Oh, and another thing too, is that this is an inner class. But nothing I said before has changed. This is a final attribute. House two, this is a final attribute. So this is an inner class. You can't exist without it. This is an outside class, but for this house, once you instantiate the house, you instantiate a room. Okay, moving on. This is a summary of dependencies. I have covered this material already, so what I need you to do is, if you need to, pause this presentation, take a screenshot, and use this as a reference. Put it all together. You can think of the dependency as a class that is used temporarily by another class. This class is taken in as an argument by a method in another class. An association is when a class uses another class as an attribute and knows about that class. An aggregation is when a class has a collection of another class. It's a has-a relationship, and a composition is when a class cannot exist, when an object cannot exist without another object. Very strong ownership. That's about as strong as of an ownership as you're going to get. Let's talk about dependency injection. So dependency injection is a design principle where a class does not create its own dependencies. What do I mean by that? So within a class, you could use a new keyword and just create an object, but we're not doing that here. Dependencies are provided from the outside. They're injected. This promotes loose coupling, testability, and maintainability. Okay, what I mean by loose coupling, that means that pieces of code can exist separately and they're not so reliant on another code. It's kind of like, okay, it's kind of like they're not so tightly coupled that you break the program if something happens to one of the pieces of code. And here's a nice little quote. Don't call new inside your class. Inject what you need. All right, let's continue. There are two types of dependency injection. There's constructor injection and setter injection. Constructor injection is the preferred mode of injection. And this is when dependencies are provided through the constructor, and the dependency that's provided through the constructor is a required dependency. You need this dependency for the object to exist. Setter dependency injection, on the other hand, is when dependencies are injected by setter methods. The dependency is optional or configurable. So a couple quotes. Constructor injection is preferred because it enforces required dependencies and produces immutable, fully initialized objects. Setter injection is useful for optional dependencies. And another nice quote, constructor injection defines what an object needs to live. Setter injection defines what an object can optionally use. All right, you're kind of wondering, why do I have these quotes in here? And that's because these are interview-ready answers. If somebody asks this on a job interview, you can respond like this. You don't have to use my voice though. All right. So here's a summary of the two types of dependency injection. And you typically want to use constructor injection because if you have a required dependency, what that constructor is going to tell you, tell everybody else is that I need this dependency. It guarantees a complete object. When you inject that dependency through the constructor and instantiate an object, you have a complete object. Okay? It supports immutability, constructor injection, and it's excellent for testability, especially when you're using Mockito and you have to inject mock objects. You're typically doing it through the constructor. And setter injection, the dependency is optional. You don't really need it. If you don't have it, you can still generate a complete class. But there's no guarantee of object completeness, and immutability is not supported. And yeah, and setter injection for testability, it's all right, but it's not as good as constructor injection. All right, we are now in our IDE. Let's take a look at this class. So this class is called rental service. And I have designed this class to demonstrate the different kinds of dependencies, as well as to discuss dependency injection. So let's start with the lowest form of dependency, which is right here. So if you look at line 28, we have this method called process payment. And essentially what it is doing is it's taking an instance of the payment processor class. So it's taking in this processor object and temporarily using it as an argument in this process payment method. So that's what dependency is. Going down the list, we have an association. So the association is where you have a class being used as an attribute by another class. So you have an instance of the manager class being used as an attribute of the rental service class. Below that, we have an aggregation. And in this case, you have a list of cars being used as an attribute of rental service. So you have this aggregation of cars being used in rental service. And then, of course, you have composition. And in this case, we have our private final attribute receipts here. And if you look at the constructor, in this constructor, once you instantiate the object rental service, you will create a new receipt. Just think about it like this, okay? You go to like Enterprise rent a car, okay? You have a rental service object called Enterprise. You go there, let's say I flew from Texas to Virginia and I want to rent a car. I rent this car and it prints a receipt, okay? But without that rental service, you wouldn't have a receipt. So you have a composed object. This receipt is part of the rental service. Without rental service, there are no receipts. Okay, now let's talk about dependency injection. So here you have a constructor and it's taken in a list of cars as a dependency. Okay, this is a needed dependency. Okay, this is not an optional dependency. This is a required dependency. Without a list of cars, you can't have a rental service. And think about it in real world. If you got no cars, you don't have a rental service. Okay. And then we have setter injection, where a manager object is taken as a dependency. It's and injected through a setter method. Okay. And this is an optional dependency. I mean, in the real world, managers are important, but you can probably live without a manager. Okay. Anyway, let's go to our runner type class and see how this plays out. All right, so here we have our dependencies and we have our injector examples. So we're setting up our dependencies. We have our list of cars. We have a Mercedes and a Cadillac. We're adding the cars to our list. We're instantiating a new manager. We're instantiating a payment processor, which is going to be used for dependency. Okay. Here we instantiate a rental car, a rental service class, and we inject cars through the constructor. So this is constructor injection. We're taking a list of cars and injecting it as a dependency through the constructor of rental service. And once this rental service object is instantiated, it will be a complete object with cars. And then, of course, we have setter injection, where we're taking a manager object and injecting it through a setter method called setManager. And this is an optional dependency, as I said. You need cars because you need to be able to rent out the cars, but you can go without a manager, at least for this rental service. All right. Then, of course, here's our dependency. So here we're taking this payment processor and using it as an argument for this process payment method. Okay. And of course, we have our association. So this is going to print out the list of cars that we have as an attribute. So this will print out our list of cars. So it should be actually no. I just make it's an association, not an aggregation. It was print out a manager because the manager is an attribute. Okay. Now we have aggregation. So here we're printing out the list of cars because that list of cars is an attribute of the rental service class. And then of course we have a composition. So the only way you're going to know about the receipt that I was mentioning is when you instantiate the rental service class, then it's going to print out the receipt. And the receipt is printed whenever a receipt class is instantiated. So let's see if we can get to this receipt class. Okay, so here's our receipt class. And here we print out receipt created. So let's go back to our run dependencies. And let's run this. Okay, so receipt created. So this is where our rental service object was instantiated and receipt was created. Anyway, pretty much goes over what I just said. So anyway, that's dependencies and dependency injection in a nutshell. Thank you very much for your time. Please subscribe. And I'm out.